Alright, we want to find the limit of this trig function. It's a secant function, but there's also some secants and stuff going on the inside. Alright, now this is an important question to answer here. Is this thing continuous? Alright, well, the secant function is continuous. Remember, it's 1 over cosine. It's continuous everywhere except for the places where cosine is equal to 0. So cosine is equal to 0 is cosine is equal to 0 when theta is, if you think about the unit circle, cosine is the x-coordinates, and the x-coordinates of the unit circle are 0 right here at pi over 2, and then you go down again at 3 pi over 2, and the x-coordinates are 0. Alright, and then again at 5 pi over 2, and 7 pi over 2, and 9 pi over 2, all the odd pi over 2's. And then if you go back the other way, same thing, the negative odd pi over 2's. So it's one of the ways you can write it is pi over 2 plus k times pi, where k is just some integer. That's all the places that this thing's equal to 0. Now, where would this be equal to pi over 2? Or this interior part, the stuff that's inside the parentheses, is what's going into secant. So all of this would have to be equal to one of these pi over 2 values for it to be not continuous, for it to be one of the asymptotes of the secant function. Alright, but when we're approaching 1, if you look, when we're approaching 1, we'd have a 1 right here. So 1 times the secant squared of 1 minus the tangent squared of 1, and then a minus 1. So that's what we would be approaching if we just plug 1 in here, or if we're approaching 1, if this thing were continuous, then this is what the limit of that interior thing would be. And if it's continuous at this point, then we literally can just plug in there. Okay, so the question then becomes, is there any way that this right here is either not continuous or is approaching pi over 2? Well, the nice thing is there's another secant function, so this part right here is once again not continuous if we plug in pi over 2, but it's continuous everywhere else. An odd multiple of pi over 2. And then the tangent function, tangent is sine over cosine. So sine over cosine, because of the cosine in the denominator again, this is not continuous anywhere that we have an odd multiple of pi over 2 also. Alright, 1 is not an odd multiple of pi over 2, so 1 can go directly into these two right here. And then the question becomes, does all of this produce an odd multiple of pi over 2? Because that all is going into this secant function. So if it does, then we're in trouble. We have to evaluate the limit differently. We would have to try to do something different. But it's not going to, and I'm going to show you why. So if you recall from trig, there was this identity, the sine squared x, and x could be anything, plus cosine squared x was equal to 1. Alright, that's the one everybody remembers. There are actually two more. These are called the Pythagorean identities. They're called that because if you put a point anywhere on the unit circle, remember the unit circle is cosine for x and sine theta for y. And if you drop down, there's your x, and you go up, that's your y. And because it's a unit circle, the radius is 1. And so we get x squared plus y squared equals 1 squared, or x squared plus y squared equals 1. But since x is cosine and y is sine, we can say cosine squared plus sine squared equals 1. Alright, so that's the Pythagorean identity that comes from the Pythagorean theorem. The other two Pythagorean identities come from dividing through the equation by sine squared or cosine squared. So for this one, Notice if you see secant and tangent, or sorry, a trig function squared, another trig function squared, and especially if you see a 1 in there with it, then more than likely you're going to use the Pythagorean identities. So I'm going to divide through this equation by cosine squared because there's tangent, and that's sine over cosine, and then secant is also 1 over cosine. So what do we end up with? This is tangent squared. This is 1. Anything divided by itself is 1. And then 1 over cosine is secant squared. Okay? Now this says if we square the tangent of anything, add 1, we get the secant squared of that same thing. These two things have to be identical. Well, notice when we plug 1 into this thing, this simplifies to secant squared of 1. That's not a nice, pretty rational number. And the tangent squared of 1. So the things that are going inside of the secant and the tangent are the same thing, 1 and 1. And this says that this identity holds when these things that are going into secant and tangent are identical. All right, and it is. So if I were to notice, I got secant squared minus tangent squared. If I were to subtract tangent squared over here from both sides, this identity over here becomes 1, that's the only thing left on the left, equals secant squared x minus tangent squared x. So any secant squared of anything minus the tangent squared of that same thing is always equal to 1. So this part right here, according to that identity, is just 1, and then we subtract 1, 1 minus 1. Now, all of that, notice all the way along, all of that was inside a secant function, right? It was the secant of all that stuff. So the secant of this. And then finally we're left with the secant of 1 minus 1 is 0. So what is the secant of 0? Again, go to your unit circle. 0 is our angle, so that means we're over here on the positive x-axis. That's the point 1, 0. Remember, cosine is the x-coordinate. So the cosine of 0 is equal to 1. That means the secant of 0 equals the reciprocal of that, 1 over cosine of 0. The cosine of 0 is 1, so 1 over 1, which is still 1. So the secant of 0 is also 1. Alright, so what is the limit? The limit as y approaches 1, because this is continuous at 1, this is continuous at 1, and all of this inside is continuous at 1, we can simply plug 1 into the problem, and we end up with a limit of 1. Now you could also have put this into Desmos. Let me do this over a little so you can see it. So I put this is the thing that we're taking the limit of at 1, and this is 1. This is where we're taking the limit. And if you look really closely, this is actually just because it gets so dense inside here, inside the function. This is actually a misprint. The secant should never go between -1 and +1. So I don't exactly know why it's doing that, but it apparently just got too dense and it couldn't handle it. But anyway, right there is 1. That's the number we're approaching, and you see the output there is 1. So as we approach from the right, we're approaching 1. As we approach from the left, we're approaching 1. So that limit truly is 1 as we make our way from both the left and the right. So that means it is the overall limit.